Day 14.
Okay, for division, remember any fraction bar is the same thing as a division sign. So you can think of this as 12 over x minus 1 divided by 6 over x. And then you can flip the second fraction, so 12 over x minus 1 times x over 6. And I would jump right from this to this. You don't need to do this. Okay, so we're going to cancel. 6 goes into 12 two times, so your final answer is 2x over x minus 1. Okay, so I'm going to do this. I'm going to say this is k plus 1 over 2k times 4k over 3k minus 1. And I'm going to cancel this k with this k. And I'm going to cancel. 2 goes into 2 once and into 4 twice. So our final answer is 2k plus 1 over 3k minus 1. And you can leave it like this. There's nothing wrong with doing that. If you want to distribute the top, you can say 2k plus 2 over 3k minus 1. Either one would have been fine. I would have just left it like that. Okay, to save some writing, I'm just going to move this up here, and this is going to be 15 over 12 x squared z to the 5th, and then I'm going to start canceling. 3 goes into this 3 times, into this 5 times. 4 goes into this once, into this 3 times. I can cancel the entire x squared. 2 of those with 2 of those. And finally, I can cancel the z squareds, all of those with 2 of these, making that a 3. So when I finally multiply across the top, I'm going to have a 5x squared on the top. And on the bottom, we're going to have a 3 times 3, which is a 9z cubed. And there's nothing else you can do. Okay, in this problem we have multiple terms in the numerator and denominator. So I'm not going to do it like the last one. I'm going to multiply the top and bottom by the LCD, which is x. And then when I distribute this in, I'm going to cancel in the first fraction and get a 1. And then when I distribute to that 1, x times 1 is x. When I multiply in the first fraction here, I'll get negative 1. And then 1 times x is a positive x. And that's all you can do there. I just distributed this on the top and on the bottom. Okay, again, we have multiple terms in the top and the bottom, so I'm going to determine the LCD, which is xy. So I'm going to multiply everything by xy. And I'll just do that here. I'll multiply this by xy, this by xy, this by xy, and this by xy. And then I'm going to start canceling. In this first fraction, the x's cancel. In the second fraction, the y's cancel. Down here, the x's cancel, and down here, the y's cancel. So you're going to be left, when we multiply across, with 3y plus 3x up top. And on the bottom, we're going to have 3y minus 3x. But that's not simplified because we can factor a 3 out of the top and on the bottom. When we factor out of the top, we're left with y plus x. On the bottom, we factor out the 3, and we're left with y minus x. And finally, these 3's can cancel. So our final answer is going to be y plus x over y minus x. And nothing else can cancel. Okay, so I'm going to factor the numerator of this one. And this, I'll pull out an 8, and I'll be left with x minus 3y over 10. And then instead of using, I'll think of this as a division symbol, so I'll multiply by the reciprocal. I'm going to bring this up and flip it upside down. So I'll have 5 over x minus 3y. And then I can start canceling. X minus 3y cancels. And then I can say 5 goes into 5 once and into 10 twice. And finally, 2 goes into 2 once and into 8 4 times. So I'm going to multiply across the top and get 4, and across the bottom and get 1. But I'm not going to write 4 over 1. I'll simplify that and just write 4. Okay, in this problem I have one fraction on the top of the division bar and 2 fractions on the bottom. So I'm going to multiply each of these fractions by the LCD, which is xy. So I'll multiply this by xy, this by xy, and this by xy. Okay, so here that xy cancels, here the y cancels, and here the x cancels. So in the numerator, I'm left with x squared minus 16y squared, which I'm going to have to factor in a moment. In the bottom, I'm left with x minus 4y. So this numerator is going to factor as the difference of 2 squares. We put the x in the first position, the 4y in the second position, and these are conjugate pairs, so a plus and a minus. In the bottom, we have x minus 4y. And that factor cancels completely, and we're left with x plus 4y. Okay, in this fraction, we have 2 fractions in the numerator and 2 fractions in the denominator. If I look at all of the denominators, I can see that the LCD is 9y. So I have to take this and multiply by each of the fractions. So I'll multiply this by 9y, this by 9y, this by 9y, and this by 9y. And then I'm going to start canceling. Nothing cancels in the top left, and I'm left with 9y squared up there. In the top right, I have 3 goes into 3 once and into 9y, or into 9 3 times. So I'm taking a 3y and distributing it in here. It's actually a negative 3y. So when I distribute it in, I get negative 3y squared from the first term, and then it's going to be plus, because I'm multiplying a negative times a negative, and I get plus 9y from the second term. Okay. In the denominator, the 9's cancel, and I'm going to get 4y from the first term plus, and then I cancel, 3 goes into 9 3 times, and then the y's cancel, and I'll get 3 times 2 is a 6. Okay, now I'll combine like terms in the numerator, and I'll get 6y squared plus 9y. In the bottom, I still have this. Okay, now I'm going to factor the numerator. There's a 3 and a y common to both of them. So I pull out the 3y, and I'm left with 2y plus 3. In the denominator, 2 is common to both of them. So I pull out the 2, and I'm left with 2y plus 3. And I cancel, and I'm left with 3y over 2. Okay, in this problem I have 2 fractions in the numerator and 2 fractions in the denominator. The LCD, well, the only 2 denominators are x and x plus 2. So the LCD is the product of those. So I'm going to take that and multiply it by each one of the fractions. And then I'm going to start canceling. In this first fraction, x cancels. In the next one, x plus 2 cancels. In this, the 5 cancels. And in this one, x plus 2 cancels. So over in the top, I have x plus 2 times x plus 2. I can FOIL that, or if I remember the shortcut of squaring a binomial, I can jump right to the answer. In either case, you're going to end up with x squared plus 2x plus 4. Then in the top right, I multiply x times 1, and I have plus x. That's the numerator. In the bottom left, I'll distribute this 5 into the x plus 2, and I'll get 5x plus 10. And in the bottom right, I have x times x, which is x squared. Now I'm going to clean this up, and I'm going to put everything in order. So on the top, I have x squared plus 3x plus 4. And in the bottom, I have x squared plus 5x plus 10. Okay. Oops. I made a mistake. My binomial is not x squared plus 2x, it's x squared plus 4x plus 4. Oops, sorry about that. So when I combine like terms, this should be a 4x plus 1x is a 5x. Now, the top is factorable, but the bottom is prime. I'm not sure if you can see that, but that's the case. So even if you factored the top, you're not going to be able to cancel with anything because the bottom is going to stay like it is. That's prime. So I'm just going to circle this as my final answer. I'm not going to bother to factor the top. All right, number 21 wants us to add the fractions in the numerator. Okay, so when we add the fractions in the numerator, we have 4 over m plus 2 over m, let's give myself some room, over m minus 1. Okay, so the common denominator looks like it's going to be m times m minus 1. So the first fraction we have to multiply by m minus 1. So the second fraction we have to multiply by m. So up in the top of the first fraction we'll have 4m minus 4 and the top of the second fraction we're going to have m squared plus 2m. So we're going to have, combining the numerators, we're going to have m squared plus, well, 4m plus 2m is 6m. And then we'll have minus 4 over this denominator. And that's simplified. We're not going to be able to simplify it any further. So that's number 21. Okay, number 22, they want us to subtract in the denominator. So we have m plus 2 over m, and I'll give myself some room, minus 2 over m minus 1. So the common denominator is m times m minus 1. So let's multiply that in the numerator and denominator of the left one. And the second one we'll have to multiply by m. Okay, so in the numerator of the first fraction, we're going to FOIL. And the first is m squared. The outer is a negative m. The inner is a positive 2m. And the last is a negative 2. Minus 2m over this. So when we combine like terms, we're going to have m squared. We have a negative m, a positive 2m, and a negative 2m. That combines to a negative m. And we also have that negative 2. But now the top we can see is factorable. This is m minus 2. Well, it's not going to help us. We're not going to be able to factor, to simplify. So we could have just left it as see, nothing's factorable, so we could have just left it like this. Okay, number 23 wants us to divide the answer from number 21, and this is the number 21's answer, with the answer from number 22. And that's that answer there. So when we divide, remember you have m, the first item, and I'm going to change it to a multiply and flip the second fraction upside down. And now we can see that all the m's cancel and the m minus 1's cancel. That entire thing cancels. And we're going to be left with m squared plus 6m minus 4 for the first one, and m squared minus m minus 2 on the bottom. Okay, for number 24, it tells us to go back to the original fraction, which I've written right here on the top left, and it wants you to find the LCD. So the LCD is m times m minus 1, because those are the only two denominators being used. And it wants us to multiply each of the four fractions in it by that. So I'll multiply this by m times m minus 1, this times m minus 1, this one, same thing, and this one, same thing. Okay? And then we're going to start canceling. M cancels here, m minus 1 cancels there, m cancels there, and m minus 1 cancels there. So in the top left, I'm going to take this 4 and distribute it, and I'll get 4m minus 4. In the top right, I'll take this m and distribute that. So I'll get a plus m squared plus 2m. And when I combine like terms, I'm going to get, in order, m squared, 4 and 2 add up to 6m, and then we have the negative 4. So that's the numerator. In the denominator, this is a binomial times a binomial I have to FOIL. My first is m squared. The outer is a positive 2m. The inner is a negative 1m. And the last is a negative 2. And then I have this multiplication, which is a negative 2m. So when I combine like terms there, I'll have m squared, and I have a negative m, and then I'll have a negative 2. And that's all I can do. And that's the exact answer that we got when we did all that other, rigmarole. But this was a lot quicker. Okay, when we do this, if we rewrite this, remember, any negative exponent is the inverse of that. So this is like this. And then we can, the LCD in this case is x squared y squared. So when we multiply the top by x squared y squared, and we multiply this fraction by x squared y squared, and this fraction by x squared y squared, we can do some canceling in the denominator. That cancels, and that cancels. So we're going to be left with x squared y squared in the numerator, and in the denominator we'll have y squared plus x squared. And that's all we can do. There's nothing else that can be done to simplify. Okay, so let's write this as fractions so it's a little easier to see. We have 1 over x squared plus 1 over y squared. In the denominator, we have 1 over x plus 1 over y. And the LCD is x squared y squared. So let's multiply each of these four fractions by that. I multiply this first one by that, this one by that, this one by that, and this one by that. Okay, now I'm going to start canceling. This entire x squared cancels. The entire y squared cancels. One of my x's cancel, and one of my y's cancel. So I'm going to be on the top, when I multiply, I'll get y squared plus x squared. And in the denominator, I'll get x y squared plus x squared y. And you can leave it like that. The denominator is factorable, but it's not going to help you. So I wouldn't factor it, but you can factor it if you want. You can take out an xy out of the denominator, and you're going to be left with y plus x. But that doesn't help you cancel anything, because you still don't have a complete common factor across everything. So you could have written it like this on the right. I would have just left it like that on the left. Okay, we're going to rewrite this. Up top here we have 1 over x plus, now be careful, only the y has the exponent, the 2 does not. So the 2 remains in the numerator, but the y is the thing that's inverted. In the bottom we just have this. Okay, so our LCD is xy. So I have to multiply every one of these terms by xy. And in the top, the x's cancel, and then those y's cancel. So I'm left with y plus x in the, y plus 2x in the numerator. And in the denominator, I have 2xy squared from this term plus 4x squared y in the second term. Okay. Now, in the denominator, I can factor. I can take a 2xy out of each of these items, and I'll be left with a y plus 2x. In the top, I can't factor that at all, so I'm just going to write it down again. But now I can see that I can cancel. This entire factor cancels with that entire factor. So I have a 1 left on top and a 2xy in the denominator. And that's the final answer.